Hi viewers, this is Sri Ramlu, degree lecturer in physics. My YouTube channel is s space physics. So there is a space in between s and p physics. So this is a space. Okay, let me explain the today's topic: entropy of universe. Okay, what about the entropy of universe? Whether it increases or decreases, that is we have to know here. Entropy of universe. The entropy of system remains constant in a reversible process but increases in all irreversible process. So already we have learned the entropy of a reversible process cannot change, but the entropy of irreversible process, what happens, increases. Okay, irreversible process entropy always increases. Therefore, there is no change in entropy of universe due to the reversible process. Yes, why? Because if any all the processes are taking reversibly in the universe, then what happens? No change in entropy occurs. But universe is not a reversible. Universe cannot have reversible process. Universe is always have irreversible process. So that is why its entropy increases while the entropy of universe increases due to irreversible process. Why? Because all the processes which are taking place in the universe are always irreversible. So that is why entropy of irreversible process increases. Since since all physical operations in the universe are irreversible, hence entropy of universe increases. Okay, so all physical process, whatever we are doing, all the processes are physical processes are irreversible process in this universe, so that is why its entropy increases. And there is a proof also, so I will upload that also, so please watch that video, don't forget. Irreversible, how the what is the entropy of entropy in reversible and irreversible process also. uh, PPT I will upload, so please watch that one also. Okay, one. Next, certain examples are there. So I have given here only two examples. And what are those two examples? So first one, ferromagnetic to paramagnetic transition. It is N. Ferromagnetic to paramagnetic transition. So that means when a magnetic material changes from ferro to para, what happens? Okay, that is we need. When temperature of a ferromagnetic material is raised above its Curie temperature, the magnetic material suddenly loses its ferromagnetism and become paramagnetism. Yes, am I right? So here ferromagnetic material means all the dipole having the same direction. So that means they aligned in parallel. Okay, in which? In ferro. They aligned in parallel. All the dipoles are. But if we apply the heat energy temperature, this alignment, what happens, become random. That means dipole moments are random. So randomness means what happens? Order means less entropy. Random means disorder. Disorder means more entropy. So here entropy increases. In the microscopic picture, the magnetic moments of ferromagnetic materials are mostly aligned in one direction. That means ordered. Okay, so in which? In ferro. Above Curie temperature. Curie temperature means what? Suppose it is a ferromagnetic material. You are applying the heat energy. Then suppose at a particular temperature, if it converted into para, if a particular temperature, if it converted into ferro to para, then that particular temperature is called Curie temperature. Okay, at Curie temperature only ferro becomes para. Above Curie temperature, the magnetic moments are randomly oriented. Randomly oriented means disorder. Okay, to produce paramagnetic behavior. Okay, in paramagnetic material, molecules are magnetic moments are random in direction. Okay, here order. Okay, so in a ferro order, but in para disorder, that is random. Hence entropy hence entropy increases in the phase transition from ferro to para. Okay, right? So order to disorder we are moving. Order to disorder moving means what happens? Entropy increases. Second question, heat conduction. In the case in the case of conduction of q quantity of heat from one end to other end of a metal bar from a high temperature reservoir to a reservoir at a temperature T1 to a low temperature reservoir at a temperature T2. There is a no change of phase volume or temperature of the conductor, but entropy of universe increases. So how? Suppose it is a one material I have taken like this. Okay, I am heating this end. So when we heat this and what happens? Here already this material means that it is a solid state material. So when we heat, what happens? The molecules start vibrating in random direction. Okay. Suppose if it is a liquid state, let me take a good example of liquid state. Suppose water is flowing in order. So all the molecules are moving in this direction. If I heat it, what happens? Instead of moving molecules in this direction, they may move like this, or they may move like this, they may move in this manner. So what is happening here? Their order is decreasing. That means they are converting into disorder. So disorder in converting means entropy increasing. So here in mathematics form also given. Yes, final means entropy, change in entropy it is of a system is always zero. Okay, but entropy, change in entropy, yes final minus yes initial means change in entropy it is. Change in entropy of water reservoir is q by t. So already we know the change in entropy formula is what? It is simply q by t. Okay, so change in entropy is q by t. Okay, heat by temperature, but heat is taken as a q, and there are the two different temperatures. So let me write for this temperature this one, and for this temperature change in entropy this one. For it is a cooler one, it is hotter one. Hotter one gives a heat energy and cooler one gains heat energy. Then their difference is what we write like this. Okay, entropy of the entropy change of universe is positive because T2 is less than T1. So it is hotter body, it is a hotter one, it is a cooler one temperature, but their heats are same. Okay, so keep it like this. But as a T1 is higher than this one, then what happens? This quantity is very much less, and it is negative. So less and negative can be removed and it becomes positive. So that means entropy of universe is more. All the examples are involving in irreversible process shows that entropy of universe increases. Why? Because here positive terms we are getting, so that is why entropy increases. Okay friends, don't forget this video watching till the end. Okay, thank you.